welcome back to our report. Today I am here with a new topic, refractive index. Now first, so what is refractive index? We know that when light travels from one medium to the other obliquely, then it bends in the second medium. The extent of that bent light is expressed in the terms of refractive index. Now first we will be discussing about the relative refractive index. Now this is the interface of two media. This is the incident ray, so this would be the refracted ray because glass is a denser medium than water. So this is the angle of incidence and this is the angle of refraction. Now this can be represented as, refractive index is represented by the letter N. In some books it is represented by letter U, but in NCERT it is represented by the letter N. Now how can we represent the refractive index of a light ray traveling from water to glass? Now I am considering water as W and glass as G. So it is represented as W and G. Now this is equal to the speed of light in water upon speed of light in glass. That is, the refractive index of a light ray traveling from medium 1 to 2 is the speed of light in medium 1 upon speed of light in medium 2. Now, another relationship between the refractive index of a light ray traveling from medium glass to water and the refractive index of a light ray traveling from water to glass. Now, G and W. This is the refractive index of a light ray traveling from glass to water is equal to the reciprocal of the refractive index of a light ray traveling from water to glass. That is, the refractive index of a light ray traveling from medium 1 to medium 2 is the reciprocal of the refractive index of a light ray traveling from medium 2 to medium 1. Now, suppose if water is replaced by air or vacuum. Then the refractive index so formed is known as the absolute refractive index. So absolute refractive index is the refractive index where one of the mediums is air or vacuum. Now how can we calculate the absolute refractive index? There is a formula for it, and the formula is C upon V. C is the speed of light in air or vacuum, that is 3 into 10 to the power 8 meter per second. And V is the speed of light in medium about which we are talking. Now, have you noticed I am saying air or vacuum? So are they same? No, they are not same. The speed of light in air is 2.9970 into 10 raised to the power 8 meter per second. And the speed of light in vacuum is 2.9979 into 10 to the power 8 meter per second. Now there is a very slight difference between these two values. So for easy calculation, we take the value of speed of light in air or vacuum 3 into 10 to the power 8 meter per second. It is taken as 3 into 10 raised to the power 8 meter per second for easy calculations. Now, friends, please note that refractive index depends upon first, the color of the incident light, and second, the nature of the material of which the medium is made. Now there is a book table in the NCERT book. Table 10.3 on page number 1.175. We can refer to it. The lowest refractive index is given of air, which is 1.0003. And the highest refractive index is given of diamond, which is given 2.42. Also please note These are the absolute refractive indexes, and in all these cases yellow sodium light is used. So now the question is, why do we need to calculate the refractive index? Now, to make lenses for optical instruments like microscopes, telescopes and DSLR cameras, we must have an accurate knowledge about the refractive index of glass, because lenses are made of glass. Like I have this lens with me. This is of my Canon 1300D DSLR camera. Now you can see that this is a convex lens because it is bulged outwards. Now when the light rays are traveling from the air, so when they enter the glass, they refract and they converge at the meet at a point to form a sharp image. Now same is the case with my telescope lens. This is the lens of my Celestron 8-inch telescope. See. This also has a convex lens. Now it also works on the same principle. Now the question is that why does the light refract? Because glass is a denser medium than air. Wait, am I talking about mass density? No, I am talking about optical density. Also, in the previous videos when I used the terms denser or rarer, or whenever I'll be using them in the next tutorials, with respect to light, then I'll always be referring to the optical density. Now, let's understand it better with the help of an example. Now, have you ever noticed that if we put some drops of kerosene on water, then they float on water? That is because kerosene has lower mass density than water. But if we check in this table, then kerosene has higher absolute refractive index than water. So, now there is a relationship between the refractive index and the optical density. And the relation is refractive index is directly proportional to optical density. That is, higher the refractive index, more the optical density. So, kerosene has more optical density than water. Friends, never get confused in mass density and optical density. Now friends, I am using terms many times: optically rarer, optical denser, optical density. But what do they mean? Optical density is the ability of a medium to bend or refract the incident light. So that was all for today's video. Keep liking, keep subscribing and keep suggesting how can I make the video better. Thanks for watching. Bye bye.